Alright, this is going to cover lecture on ionic compounds with using these polyatomic ions. So let's talk about what is a polyatomic. So if you break the word down, poly means many. So we're talking about two or more elements in a as acting together as an ion, so they have a charge. We previously talked about binary, where we had just two elements, a metal and a nonmetal, or a cation and an anion. But here we're going to have more than two atoms bonded. And the thing with polyatomics that many kids don't do is they don't actually memorize your polyatomics. So on the back of your periodic table is some common polyatomic ions. So you can use that for a cheat sheet or a quick reference. But there are certain ones that you will need to know, okay? And you need to know the name of the polyatomic, sulfate, sulfite, phosphate, and then you need to know the formula and its charge. And there's no easy way around it. You just have to memorize them. So I suggest making flashcards. So let's look at exactly what is a polyatomic ion. A polyatomic ion is a group of two or more elements that have an overall ionic charge. So these have an overall ionic charge. Most times the polyatomic ion will function as an anion, but there are cation polyatomics, polyatomics with positive charges. Reconnect here. Most of them are going to be a negatively charged polyatomics. Okay, so in looking at these polyatomics, they have a charge. Okay, and let's kind of look at one real simple here. Hydroxide. Hydroxide is an O and an H, and it has a -1 charge. Well, oxygen has a -2 charge, and hydrogen has a +1 charge. Now, you might be thinking, wait a second, you always have to write the cation first. Well, then this is the exception to the rule of that. So overall, this has a -2 and a +1. We have one oxygen, one hydrogen, so the overall charge is a -2. If we look at phosphate, phosphate is PO4. This whole thing right here has a -3 charge. So this whole thing here acts as a -3 charge. Oxygen has a -2 charge. And since we have two of these, so the charge of the phosphorus plus the charge on the oxygen, and that charge is going to be 4 oxygens times each one having a -2 charge. That's a total of a -8. And we need this to equal -3. So it's just a solve for x, so this has to be a +5. Since there's one phosphorus, this has to be a +5. So that's where we're getting, because this is a +5 and this has a -8 charge, we're going to have an extra 3 electrons. So that's where we're getting the actual charges from on the polyatomics. Again, the easiest thing is just to memorize the formulas and the charges. I would suggest that all polyatomics you write in parentheses, and what you have to remember is that they are a unit. They are a unit. So for sulfate, -2 charge. You're not going to do anything. If it says sulfate, it's SO4. You're never going to change inside the parentheses. You're never going to change this to a 2 or a 3 or a 14, because then it's not sulfate anymore. So you really can't, you're not going to ever change the numbers. Okay, if it says sulfate, it's going to be SO4, and it's going to stay SO4 for the most part for now. Okay, so that's what this is. Just, you can't change any of the information inside the parentheses. So just whenever you get to see a polyatomic, just go ahead and put it inside the parentheses. Inside the parentheses, and leave the parentheses there. Okay? So it says think of these as being protected. When you cross, you're going to cross your numbers outside of the parentheses. They're going to go right here. So whenever you crisscross, the number is going to go outside the parentheses. And that's going to say, hey, whatever this number is, it's distributed to both of the atoms. We do it just like writing binary compounds. The only difference is one extra step. Okay, so let's look at the steps here. The first step is write the symbol with the cation, and that goes first. Cation goes first. There we go, aluminum. We're right, aluminum. So you just look at your periodic table, aluminum plus 3. And to the right of that, you write the polyatomic. Polyatomics are going to end in ites or eights. So if you see an ite or an 8, you got to go, okay, that's a polyatomic. You could spend all day looking on the periodic table for an ite or an 8, but you're not going to find it. Okay? IDEs, then you look on the periodic table. If it ends in IDE, then you go and look at the periodic table. But ites and 8s are polyatomic, so you need to have those memorized or look on your common polyatomic sheet. So, phosphite. You look on the polyatomic sheet, and there it is right there. PO3 with a negative, put it in parentheses, and it's got a -3 charge. And then basically it's the same as binary. You're just going to crisscross. Okay, so write it a little bit larger here. Again, you're going to crisscross this 3 here, the aluminum, and this 3, the +3, outside of the parentheses. Again, you can't change inside the parentheses. Inside the parentheses is protected. Okay, and then you got 3-to-3 ratio, and you check. Can I reduce this 3 and this 3? And I can. I can factor out a 3. You're not going to change this 3. Again, you can't factor out this 3 right here on the PO3 because that would change the phosphite. It wouldn't be phosphite anymore. And it's saying, hey, you got a phosphite. All right, so there's our final. So it's going to take 1 aluminum and 1 phosphite. Okay, since it's a 1-to-1 ratio, we don't really need the parentheses, so you can get rid of the parentheses. Just to kind of help you memorize these, a lot of these are only differ by one name: phosphate here and phosphite here. The difference is, I always say 8 is great. So if it's got the larger number of oxygen is an 8, the smaller number of oxygens is the ite. If you look at sulfate is going to have SO4, and sulfite is going to be SO3. It's going to be a -2 charge. Okay. Nitrate, same thing. All right, so let's look at an example here between calcium and chlorate. First step, you're just going to write calcium, and calcium has a +2 charge, and then chlorate. You got to be thinking, hey, chlorate, ATE, that's a polyatomic. Chlorate is ClO, 3 oxygens, and that whole thing right there has a -1 charge. Okay, next step, you're just going to take the number, the charge, and crisscross. It's going to come out to be, now here you need to keep the parentheses because the 2 needs to be distributed to everything inside the parentheses. We can erase the 1 there. Okay, so let's count atoms. We have 1 calcium. Okay, we're going to have 2 chlorines, and we're going to have 6 oxygens. 6 oxygens. Okay, but the correct formula to write this is calcium chlorate, 1 calcium and 2 chlorates. All right. Let's try this one. Again, you can stop this and try these. Ammonium. Again, you can look on your periodic table, but it's not on there, so ammonium is an NH4. And that thing has a +1. And then a nitrate, NO3. A -1 charge. And this just comes out to be NH4, NO3. I don't need the parentheses because it's a 1. When I crisscross, it comes out to be a 1-to-1 ratio. Okay, let's try some more here. And again, you can stop them and check them. So potassium. Potassium is a +1 charge. Chromate. Now, chromate is not one of the ones that you need to know. So you just go and you look on your list. Find chromate. It is Cr4 with a -2 charge. I'm going to crisscross the 2 and the 1. It's going to come K2, CrO4. I don't need the parentheses because it's one chromate. There's only one chromate and 2 potassiums. Magnesium, +2, and oxalate. Let's see. You just look at your chart there. Where's oxalate? Oxalate. There it is. C2O4 -2. Okay, so here the 2 is going to cross here, and this 2 is going to cross down here. And then you can reduce the 2's here, so it's going to be MgC2O4. How come I didn't reduce the C2O4? Because that's oxalate. That's formula for oxalate. I can't touch that formula. I can't change the numbers because then it is not oxalate anymore. Strontium, +2. Phosphate, ATE, PO4 with a -3 charge. This 3 is going to crisscross here. This 2 is going to crisscross here. SR3. Now here I need the parentheses, PO4, 2. So 3 strontiums, 2 phosphorus, and 8 oxygens, or 3 strontiums and 2 phosphates. Cesium, +1. Sulfite. Sulfite's on your list that you need to know. Sulfite, SO3. Just go ahead and put your polyatomics in parentheses. Crisscross, 2 to 1. Oops. And it's going to come CS2. And since there's only one sulfite, I can just leave it like that. Calcium, diselenite, ATE, ites and 8s. Got to check on your back of your common ion polyatomic sheet. SeO4. This is a +2. This one's a -2. At a +1, 2, -2, basically comes out to be a 1-to-1 ratio that will neutralize. Remember, all these compounds neutralize each other out. Rubidium, +1. Iodate, IO3, -1. And again, +1, -1. At a 1-to-1 ratio, they just cancel each other out. Okay, that should take care of part 1. Let's move on, and then you can watch the second recording for part 2.